Have you ever wondered how apps instantly check for repeated characters in your passwords or highlight the longest unique word streak in text analysis? That's the magic behind LeetCode's longest substring without repeating characters, a pattern mastery 100 essential and a frequent favorite in Facebook and Google interviews. Over 40% of candidates overthink this. Let's get you in the winning group. Let's tackle this using the basic framework. This lets us break down the problem, analyze trade-offs, design a clear plan, and check our work, just what interviewers want to hear. We're given a string and need to find the length of the longest substring without any repeating characters. For example, in ABCAB-CB, the answer is 3 for ABC edge cases, empty strings, all repeating characters, and mixed cases. Suppose you're designing a text editor that suggests the longest word or phrase with all unique letters for cryptography or password suggestions. This problem helps you power that feature efficiently. A brute force solution checks every substring, but that's O(n) squared time, much too slow. The optimal approach is to use the sliding window pattern with a hash map, or set, to track characters and their indices. This lets us expand and contract our window efficiently as we scan, guaranteeing O(n) time. Here's our plan. Use 2 pointers, left and right, to define the current substring window. Use a hash map to remember the last index of every character we've seen, as we scan from left to right. If the current character is already in our window, i.e., in the map and its stored index is greater than equals left, move left just past its last occurrence. Update the character's last index in the map. Track and update the maximum window size seen so far. After scanning, return the max length found. Here we import everything from java.util. We need this so we can use helpful data structures like set and hash set for tracking characters efficiently. This starts our solution class, which will hold the method that finds the length of the longest substring without repeating characters. We define the method length of longest substring that takes a string s and returns an integer, the length of the longest substring where no character repeats. We create a hash set called scene. This set will store the characters currently in our sliding window, the substring we're looking at right now. Because sets don't allow duplicates, it's perfect for checking if a character is already in our current window. We declare 2 integers. L is the left pointer of our sliding window. It marks the start of the current substring. Max_len keeps track of the maximum length we've seen so far. Think of L as the front of a queue and max_len as our best record so far. We start a for loop with R as the right pointer of our sliding window. R moves from the start of the string to the end. At each step, the window is the substring from L to R. Time complexity note. This loop runs at most n times, where n is the length of the string. Combined with how we move L, the overall time will be O(n). Now we check. While the current character s.char at R is already in our scene set, it means our window has a duplicate. So we need to shrink the window from the left until that duplicate is removed. This while loop will keep adjusting L until the character at R is no longer inside the window. Inside the while loop, we remove the character at the left pointer L from the scene set. This is like sliding the window's left edge to the right and saying, we're no longer including this character in our current substring. Then we move the left pointer L 1 step to the right. This effectively shrinks the window from the left side. We repeat this until the duplicate character is gone. This closes the while loop. At this point, we've adjusted the window so that there are no repeating characters with respect to s.char at R. Now that we know s.char at R is not in the window, we safely add this character to the scene set. The window, from L to R, is now a substring with all unique characters. We update max_len by comparing the current max_len and the length of the current window, which is R, L plus 1, right index minus left index plus 1. If the current window is longer than any we've seen before, we store this new length. This keeps track of the best answer as we go. Time complexity note. Even though we have a while loop inside the for loop, each character is added to and removed from the scene set at most once. That's why, overall, both pointers L and R move forward at most n times, making the total time O(n). The space complexity is O(-n). Charset. Since the set stores at most one of each character in the window. This closes the for loop. By now, we've checked every possible window while maintaining the no duplicate characters rule. We return max_len, which is the length of the longest substring without repeating characters that we found during the process. This closes the length of longest substring method. And this closes the solution class. And that's how this algorithm works. It first sets up a sliding window and a set to track unique characters, then moves 2 pointers across the string to expand and shrink the window while updating the best length found. Efficient, simple, and elegant. Let's test our function with this string. We're trying to find the length of the longest substring without repeating characters. as we slide through the string. Starting with ABC, all unique, length 3. When we hit the second A, we shift the window to remove repeats. Later substrings like BK or CAB also reach length 3, but none get longer. Repeated B at the end keeps the window size from growing. So the maximum unique substring length we ever reach is 3, and the program outputs 3, which matches the expected result exactly. So, our implementation is correct. The sliding window algorithm efficiently identifies the longest non-repeating substring, accurate in passing the test case. We begin by importing Java utilities so we can use the HashMap class for tracking character positions. This defines the class solution, where our sliding window logic will live. This method receives a string s and returns the length of the longest substring with no repeated characters. We create a hash map that will store the most recent index of each character we see. Think of it as a memory map that reminds us where each character last appeared. Here we set up two variables. maxlen tracks the longest valid substring seen so far. L is the left pointer of our sliding window. The right pointer will be the loop variable. We start looping with R as the right pointer, scanning the string from left to right. Each step expands the window by one character. Since each index is visited once, this loop runs in on time. We grab the character at the right pointer. This is the character we're currently adding to the window. This line checks whether we've seen this character before, and its previous occurrence is still inside our current window, meaning greater than or equal to L. If both are true, we found a repeating character inside the window, and we need to adjust. This is the key sliding window move. We shift the left pointer L to one position after the last occurrence of this repeated character. That removes the conflict and restores our substring to a no duplicate state. Closing the conditional block, we update the map to record the most recent position of this character. This ensures future repeats are correctly handled. Now we compute the length of the current window, R, L+1, and update maxlen if this window is the largest one we've seen so far. This check also runs in on time. Finish scanning the entire string. Return result. We return the length of the longest substring found. This gives us the final answer with a total time complexity of on and space complexity of O-min-n. Charset, usually O1 for ASCII letters. Closing the method. Closing the class. And that's how this algorithm works. It first initializes a sliding window and a map to track character positions, then expands and adjusts the window efficiently to ensure no duplicates remain inside it. Efficient, simple, and elegant. Let's test our function using this input, the string poq. This string represents a sequence of characters where we want to find the length of the longest substring without repeating characters. Here's why the solution works. The algorithm scans through the string while keeping track of characters we've seen in the current window. For example, starting with P substring is P. Next letter's W. We hit a repeat, so we shift the window. Later, the substring WOOC appears with no duplicates, giving us a length of 3. No other valid substring is longer than that. And that's exactly what our program outputs, 3. This matches the expected result and confirms that our sliding window logic is working perfectly. So, our implementation is correct. The algorithm successfully identifies the longest unique character substring, efficient, accurate, and reliable. So, what did we just learn? This problem, longest substring without repeating characters, is one of those perfect tests of logic and pattern recognition that shows how well you can think through a real-time data problem. Breakdown recap. We started by understanding the goal, finding the longest substring in a string that has no repeating characters. Essentially, it's about tracking a clean stretch of unique letters. Assess recap. Then we discussed why brute force just doesn't cut it. It's too slow, checking every possible substring. Instead, the optimal approach uses the sliding window pattern combined with a map or set to keep track of characters efficiently. Structure recap. We planned the logic step by step. 2 pointers to define the window, a map to store character positions, and a way to slide the window forward whenever we hit a repeat, always keeping track of the maximum length seen so far. Implement recap. We then implemented the logic cleanly and ran it on LeetCode, no errors, just a smooth execution. Check recap. The test cases confirmed everything worked as expected, and our solution passed across all examples. Closing insight. The real takeaway? Sliding window problems are all about balance, knowing when to expand and when to contract. Master this technique, and you'll fly through a whole category of string and array problems with confidence.